Good morning, good afternoon, good evening, everyone. This is module 11 presentation. This is using native SQL, MC-SQL for complex query with joins and aggregations, TDD approach with comprehensive test coverage, RESTful design following best practices, entity validation with pre-persist hooks, transaction safety with proper propagation, data integrity through unique constraint and foreign key results. Production ready API with reliable data. One of the issues that I have with this particular module is that has a lot of problem compiling with Java 21, so I have to run with Java 17 and I have to just export my Java home as having two different home for the Java. Okay, let's start the demo. So as we said before, this is module 12, is a native SQL implementations. I will demo the SQL in a bit, but it's basically a Spring Boot 3.1 with Java 17, could not run on 21, so I have to use multiple Java homes to make this application run. It's using native SQLs, and I will show you in a bit how those native SQL are working. In MySQL database with the JPA and the Hibernate, comprehensive test coverage with the JUnit and JW2 authentication for secure endpoint. And this application does not have an HTML component, so there is no HTML pages. So the feature one is the endpoints for the restaurant. The first one is list all the restaurants with filters, get restaurant details with rating, create new restaurant, update restaurant, and delete restaurant. We've been doing this since module 7, I believe. Okay, so native SQL query with Java using simple ANSYS SQL. As you can see right here in the code highlight, we select the ID, the name, and the price range from the restaurant table, and we do a left join to get the other pieces of information. So basically, this SQL right here can be copy pasted into any SQL editor, and you can run the query. And I will do that in a bit. The get API code highlight service layer. This is the product service layer. This is our public API product, where we find product by restaurant ID, and basically this is the piece of code that handles that implementation. The key feature here for the order endpoints is get the API orders, list all orders, create new orders, and update orders statuses. And this is the piece of the code that handles that particular elements. You validate the customer, if the customer exists, you validate the restaurant, get the first product restaurant, you create order with pending statuses, add products to order with validation, and you have validation logic, and then obviously you have a return and the key features. Feature 4 is automated test data generation using the data seeder Java script. I have to also modify that script to make it work with Java 17 and some compilation errors, but nothing really major. But anyway, so we reuse that data seeder that's working well, and basically this is what it does. And then we have the list of the products. You shuffle products and take first to avoid duplicates. Excuse me, I'm not feeling well still. The key feature prevent unique constraint violation through shuffling. And so we test the test coverage is we have 11 tests for restaurant endpoint, 6 tests for the product endpoint, 14 tests for order endpoints, the get plus the post, and 7 tests for order statuses. And this is the restaurant API test, and this is the Java, the decorator that handles that particular piece of the test. And all of the tests been run successfully, again. And so this is our Java, the entity, the product, the numbers. Native SQL implementation, like I said before, all repository query use the query native query for the direct database control, proper DTO pattern, using clean separation between entities and the API responses, an API DTO for responses, for requests, for order responses, and for product listing. Transaction management in Java. Again, this is the piece that handles that. And then we have the custom error handling with exception with proper HTTP statuses code, restaurant not found 404, bad request exception 400, and validation exception 400. And we use, again, we have to use the Java. Unfortunately, we had to use Java 17 because we couldn't get these Loombook compatibility issues with Java 21. Okay, so MySQL database and Maven, and using that. Yeah, so this is basically what I have to do to make it work. I have to export my Java 17 home, so I have multiple Java installations, 17 and 21. I had to install 17, which I didn't have, and I don't want to make 17 my default since I ran on 21 for quite some time. But as long as we have this, we export the home and we point to Java 17, everything runs, smoothly after that. Database auto-seeded on a startup using that data seed script. 10 restaurant, 100 product, 50 orders with line items, 20 users, employee and customer. I'm gonna do a quick demo of that. So let me move to the console and start running this. This one, basically I'm going to be querying my tables live, and here is my connection to the database. The database is still module 11 from previous model. I'm just leveraging what I created from module 11, since the tables are similar, the keys and everything else. So I didn't want to recreate a new database for this particular module. So I'm reusing it. As you can see, primary key, foreign key relationship, and the tables are all the same. Okay. So let me move this to the right so we can start writing the queries. And so this is going to give us all the product information, and it's doing quite a lot of joins. I'm not going to explain every join, but let's run it, and all the results are based on based on that Cedar database. So we have the order ID, the restaurant rating, the order status, the customer name, customer who put that order, the customer email, customer address, the restaurant name, the price range, and the product. This is joining all mostly the three tables to get this report. We get the customer information, the restaurant information, and also the product information, and the order total is calculated. As you can see, this is the order total, the line total, and the unit price. So I'm doing that calculation. I'm using inner joins to join on primary key and foreign key relationship that I explained that earlier. So let's run another query. This one is query number 2. It shows restaurant rating and order statistic. So let's run this one. And again, I'm not going to explain all the queries and all the joins, but you get the idea. So this one has the restaurant name, the restaurant ID, the price range, phone number, email, address, total orders, the total number of orders, total items sold, average rating, and the total revenue. So, and again, this doing some joins and inner joins as well. So so let's do the next one is show customer purchasing behavior. Let's analyze our customer purchase behavior, and let's run that query. and let's see what the behavior looks like. So so you have the total amount spent, the average order value, the average rating given, the last order status, the last order ID, and obviously the customer name, the customer email, the customer location, and the total number of orders. And is ordered by total orders from the one who ordered the most, which is Melissa Herminston. She has 9 orders. It looks like she likes that restaurant. Okay, so let's run the same. The next one is show which product are most orders, right? Let's run that query. And again, this, you have to do a left join and an inner join. And I'm just gonna limit this by description. Oops, let's select here. That's an error. I didn't select it all. Just give me a sec. This takes a little bit of talent. All right, there you go. So again, so product ID, product name, product description, and restaurant name, unit price, and total units sold 12, total revenue 6,000, and average quantity per order is 2.40. So this is the total units sold for that product, and the product name is Nian Now. Oh, the restaurant name, Nian Now INZ. Description for product 5, salmon. Everybody likes salmon. Okay, so let's do show current order pipeline. I think this is another one. Let's run this query, and again, I'm not gonna explain all the joins, all the cases that beyond this presentation, but I can do that. Happy to do that on a different presentation. All right, let's run it, and that's it. That's our shows the current order pipeline. All right, so order status, pending, deliver, and in progress. The count, so we got 39 orders that are in pending status, 28 that are delivered, and 24 in progress. And the percentage, the total value, and the average rating when is given. All right, so that's pretty much it for module 12. And thank you very much for watching, and I hope all of you have a fantastic Thanksgiving weekend, and I will see you next week. Thank you. Bye.